In this question, it is given that a platinum wire has a resistance of 2.62 ohm at 15 degree Celsius. So the resistance is nothing but 2.62 ohm when the temperature is 15 degrees Celsius and 3.29 ohm at 80 degree Celsius. Find the temperature coefficient of resistance of platinum wires. So we already discussed that whenever we are comparing this resistance, then we should write the equation as R is equal to R naught, and just remember that this R naught is not the initial resistance. This R naught is resistance at 0 degree Celsius. So this is R naught into 1 plus alpha into delta T, and we are measuring the change in temperature from 0 degree Celsius. So we can write change in temperature will be equal to, let's say, T1, that is T1 minus 0. That means at a temperature T1, the resistance, let's say, that is equal to R1. Like that, for a resistance R2, we can write this as equal to R naught into 1 plus alpha into, assume that resistance R2 is at a temperature of T2 degree Celsius. So we can write this as equal to T2. Now here we don't know what about the value of R naught. So what we'll do is we'll divide these two equations. So if you are dividing these two equations, we'll get as R1 divided by R2 is equal to this R naught and R naught get cancelled. Basically we are dividing these two equations, so this R naught and this R naught get cancelled. So we can write this is equal to 1 plus alpha T1 divided by 1 plus alpha T2. Now from this we can find out what about the value of alpha. So we can write this as R1 plus R1 into alpha into T2 is equal to, we can write this as R2 plus R2 into alpha T1. Now Rm is to find out the value of this alpha. So what we'll do is we can write this as R1 T2 minus R2 T1 into alpha is equal to, we can write this as R2 minus R1. So we can write the value of alpha is equal to R2 minus R1 divided by R1 T2 minus R2 T1. So from this we can find out what about the value of alpha. Now according to the given question, we can just substitute these values. R2 is given as nothing but 3.29 minus R1 is 2.62 divided by R1 is 2.62 into T2 is nothing but 80 minus R2 is nothing but 3.29 into T1 is nothing but 15. So we can find out the value of alpha over here. So 3.29 minus 2.62 will get us 0.67, and 2.62 into 80 will get us 209.6 minus 3.29 into 15, you will get something like 49.35. So you can write the value of alpha is going to be 0.67 divided by, this is going to be 160.25. So we'll get the answer as around 0.004180, or you can approximately write it as 4.18 into 10 raised to minus 3.